Hello everyone, welcome to the next lecture on the complex analysis. Today I will explain you the concept of radius of convergence. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the various lectures on the complex analysis as well as the PY questions series. What we have discussed so far, we have learned the concept of the power series, its convergence and the radius of the convergence. For more detail, you must watch about my this lecture of the power series available in the same playlist as you can see in the last lecture. Now, what we will discuss in this lecture, we will see how we can find the center of the power series, how we can find the radius of the convergence, and how we can find the interval of the convergence through 25 plus numerical examples. I am very sure that at the end of the video, you will be very satisfied after watching these videos. If I quickly recall you the concept of the power series, here the value of the C is known as the center of the power series. Then you can define the interval of the convergence is Z minus C is less than R, where C is called as the center of the series, power series, and R is computed either by using the equation number 1 or by equation number 2. You can use either of the formula, but make sure whenever you are using the interval of convergence is Z minus C less than R, make sure the coefficient of the Z must be 1. Then if the coefficient of the Z is 1, then this value of R is called as the radius of convergence. For example, if I say the value of the 2Z minus 3 is less than 7, clearly say the coefficient of the Z is not 1. So firstly you can make them as a 1 divided by 2 on the both side. In that case, your radius of the convergence is my 7 over 2 instead of the 7. And this value 3 by 2 is the value of the C called as the center of the power series. Here the major question arises is under what case you can use the equation number 1 to compute the value of R, under what cases you can use the equation number 2 to compute the value of R. For that I will give you some tips. Whenever you will see the value of the AN involves power of the n terms, then you can use the equation number 1. If the AN involves the factorial terms, then you can use the equation number 2. But make sure students, these are only preference. You may use equation number 1 for all those formulas and equation number 2 as well for every equation. I hope you can like and comment on the video. Now let's start with the 25 plus examples. Whenever they are asking you about the center, radius or the interval of convergence, your first target is to compare the given series with the Z minus C raised to power n. Make sure students every year in the CSIR net, GATE or any of the examinations, every year 2 questions will be asked in the examination. Definitely 2 questions will be asked in the examinations. So be patient and watch the video till the end. You will learn many techniques. So can you compare them? The value of the A will be n factorial. Now since this is the n factorial, your target is to compute the value of the R. So can you find the value of the R? You can substitute the values. What is the AN plus 1? It is 1 over n plus 1 factorial, and AN will be 1 over n factorial. So can you solve them? It is limit n approaches infinity, n plus 1, n factorial will be cancelled out. It is 1 over n plus 1. If you take the limits, it is 1 over infinity 0, 1 over 0 is again infinity. So once you can find the value of R, therefore the interval of convergence is, always remember Z minus C is less than R and the expression is Z. So Z minus 0 is less than R, value of the R is infinity. Once you can compute, now you can see the coefficient of the Z is 1, therefore center is my 0, radius of the convergence is infinity, and the interval of the convergence is mod of Z is less than infinity, or you can see minus infinity less than Z less than infinity. What does the meaning of that? It's a complete complex plane. So that means the interval of convergence is the complete complex plane, radius is infinity, center is 0. Look at the second one. Again, your target is to compare the given series with this quantity. Clearly say if you compare them, C will be my 0. That means center is my 0. What is the AN? AN will be 1 over 2 raised to power n plus 1. Now I can find the value of the R by using these expressions. Can you substitute the value of the AN plus 1? AN plus 1 will be 1 over 2n plus 1 into 2n plus 1 over 1. So this expression is written here. Now as you take as n approaches infinity, it is infinity by infinity form. So you can use the L'Hopital rule. If you use the L'Hopital rule, it will be 2 raised to power n log of 2 divided by 2 raised to power n plus 1 log of 2. So this value will be 1 over limit n approaches infinity. This value is my 1 over 2. So clearly say this value is my 2 is the right answer. Or this is the first way you can use the L'Hopital rule. Otherwise, the second way is you can divide the numerator and denominator by 2 raised to power n. So what will happen? If you divide the numerator and denominator by 2 raised to power n, it is 2 plus 1 over 2 raised to power n. Now as n approaches infinity, you all know 1 over 2 raised to power n goes to the 0. Therefore, 1 plus 0 over 2 plus 0. Again the answer will be 2. So therefore, your interval of convergence will be z minus 0 is less than 2. Now clearly say the coefficient of the z is 1. So therefore, the center of the power series is 0. Radius of the convergence is 2 and interval of the convergence is mod of z less than 2. Fine. I hope you can like and comment on the video. Okay, look at this another one. Again, your target is to compare always with the help of pair. So what is the AN? AN is the coefficient of this power of the n term. So that will be 1 over 2n plus 1, 2 raised to power n. Fine. So then your target is to find the value of R. I can use this formula. For this case, I can find the limits firstly. Limit n approaches infinity, 1 over 2n plus 3 into 2 raised to power n plus 1 into 2n plus 1, 2 raised to power n over 1. So I can make the pair of 2n plus 1, 2n plus 3 and so on. So clearly say 2 raised to power n will be cancelled, half is outside, limit n approaches infinity, 2n plus 1, I can divide it by, this will be cancelled out, fine, I can divide it by 2 raised to power n on the both side, 1 plus 3 over 2n. As n approaches infinity, this value will be the 0. So that will be 1. So the answer is half. Fine. Once you can take this limit is half, you can substitute here. Your answer will be 2. Therefore, you can see the coefficient is my 2z plus 1 is less than r. Now clearly say the coefficient of the z is not 1. So firstly you can make them, the coefficient of the z is 1. So it will be 1. So can you find the center? So always compare with the z minus c is less than r. What is the value of the c? C will be minus half. Radius will be, this is my radius. Always remember this r is not a radius. Radius is always when the coefficient of the z is 1 and the interval of the convergence is z plus half is less than 1. I hope you can like and comment on the video as well. Okay, look at this another one. Again, you can compare the given series. Your AN will be n 3 by 2. Fine. So either you can use this formula or, dear students, remember you may use this formula as well. Fine. Okay, I will tell you this example with the help of the both numerical formulas. Fine. So let's see. Firstly, you can solve by this method. So what is the value of this case is 1 over n plus 1, 3 by 2, n raised to power 3 by 2 over 1. So how you can write this quantity? I can take 3 by 2 as a common. Fine. And then it will be n over n plus 1. So what is the limit of this? As n approaches, I can divide the numerator and denominator by n. It will be 1, 1 and 1 over n. So the answer is 1. Fine. So once you can substitute here, answer will be 1. Otherwise, you can also use the second formula, that is the limit n approaches infinity, an will be 1 over n raised to power 3 by 2 raised to power 1 over n. I can write this value as well. Limit n approaches infinity, 1 over n raised to power 1 over n raised to power 3 over 2. Now since we all know limit n approaches infinity, n raised to power 1 over n is 1 always. Fine. So if you substitute here, it will be 1 over 1 raised to power 3 over 2, that is 1. That means the value of the r is 1. Either of both the cases, we will get the same answer. Now, so therefore, your target is to find the interval of the convergence. So the interval of convergence you can see from this case. Here, this is 4z minus 5 is less than 1. But you have to check it very carefully. The coefficient of the z is, coefficient of the n is 2. So you have to write here is 2 also. Fine. Whatever the coefficient of the n, you have to write the power also. So can you find the value of the z? You can see I can write this number is 4z minus 5, which is root of the 1. Root of 1 is my 1. Again, you can see the coefficient of the z is not 1. You can find it coefficient to be 1. It is less than 1 over 4. This is the required interval of the convergence. Can you find the center of the convergence? Center of the power series? You can compare with them. C will be 5 by 4. Radius will be 1 over 4. Fine. Always remember students, two questions definitely asked in the CSIR net examinations. If you want to find more lectures on the radius of the convergence, you can watch my this PY question series CSIR net, and you can watch my this lecture of the radius of convergence. You can see the CSIR net, GATE and the IIT JAM last 19 years papers solution is available with the help of the shortcut tricks. Okay, look at this next question. Again, can you find the value of the an? An will be my this quantity. Fine. Now I can find the value of the r. So can you find the limit? N approaches infinity. An plus 1. It is n plus 2. N plus 2 means it's a n plus 3. N plus 3 means it's a n plus 4 into an. N plus 2, n plus 3. Is it okay? Now you can cancel out. What will happen? N plus 3 will be cancelled out. So the remaining quantity will be limit n plus 2, n plus 2 divided by n plus 4, n plus 1. So how you can make the limit? I can divide the numerator and denominator of the each term by n. It's a 2 over n, 1 plus 2 over n divided by 1 plus 4 over n or 1 plus 1 over n. Or because you can see it's an infinity by infinity form, you can apply the L'Hopital rule as well. So can you find the limit? It's a 1, 1, 1. So it is my 1. So the limit as n approaches infinity is my 1. I can substitute this value. You will get the answer is 1. So therefore, you can find the interval of the convergence is z minus 0. Coefficient of the n is my 1, which is less than of r. So clearly say the coefficient of the z is also 1. So the center is my 0. I can say z minus 0 is less than 1. Center is my 0. Radius is my 1. And they are not talking about the interval of convergence. But if you find the interval of the convergence is z is less than 1. Look at this another one. Again, you can see your an will be 1 plus. Fine. Now since it involvement of the power, so I can prefer to use the value of the r is as n approaches infinity, an raised to power 1 over n. So if I substitute the value, it will be the limit. What will happen if you take the power 1 over n? So n will be cancelled. So as n approaches infinity, this value will be 1. So the center radius, so therefore your interval of the convergence is, what is that? The coefficient of the n is my 1. So z minus 0 is less than 1. So coefficient of the z is 1, center is my 0, radius is my 1. Look at this case. What is the an? An will be your log of n raised to power n. Again the power n is appears, so I can use the same formula, this one. So what is the answer of this? It is limit n approaches infinity. It's a log of n. N and n will be cancelled out. So what is the log of infinity? It will be 0. So therefore you can define the convergence is z minus 0 is less than r. So that means the center will be 0, radius of the convergence is also 0. And if you want to find the interval of the convergence, interval of convergence will be z minus 0 is less than 0. But z can never be negative. So that means this power series is convergent only at z is equal to 0. Okay, look at this another one. In this case, your target is to write again in this manner. Fine. But if you look at all these previous examples, the value of the an is already given to you. But in this case, your target is to write the an. Now it's a very simple. If you look at this term, 1, 3, 5, what is the meaning of that? This is my arithmetic progression, AP. So what is the nth term of the AP? A plus n minus 1 into d. A is my first term, n will be n, common difference is my 2. So if you open them, it's a 2n minus 1. So the numerator becomes 1, 3, 5 and so on. It will be 2n minus 1. Similarly for the denominator, it is 2, 5, 8 and so on. Again it's AP. Again the common term is my A plus n minus 1, common difference 3. So it will be 2, 5, 8 and it will be my 3n minus 1. Now you can see the power. When you take n is 1, it will be my 1, it is my 2, fine, and the value of the z is my 1. So this is my an. Clear? Now your target is to find the limit an plus 1 over an as limit n approaches infinity. So what is the value of the an plus 1? So if I find the value of the an plus 1, it will be 1, 3, 5, 2n minus 1. And if you replace n to be the n plus 1, it will be 2n plus 1 divided by 2, 5, 8. It is 3n minus 1. If you take n to be the n plus 1, it is 3n plus 2. Fine. Now you can substitute an plus 1 and an. You can divide them and you can see 1, 3, 5, 2 and cancel out. 1, 2, 5, 8, it will be cancel out. So this expression becomes as n approaches infinity, 2n plus 1 over 3n plus 2. So it's an infinity by infinity form. You can apply the L'Hopital rule. It's a 2 over 3. Therefore, z coefficient will be minus 0 is less than r. Fine. There is my fine. No, sorry. Still your target is to find the value of the r. So r will be my 1 over limit an plus 1 over an. So the value of this will be my 3 by 2. So can you find the radius of the convergence? Z minus 0 is less than 3 by 2 and the coefficient of the z is my 1. So this value of the 3 by 2 is known as the radius of convergence. Again, your target is to prove that it's a unit radius of convergence. Can you define the an? You can see it's a plus 1, a plus 2 and so on. I can write a plus 1, a plus 2 and so on. And last term will be, you can see it's a 3, it's a second term. Fine, it is a 1. So I can write this is n minus 1. Similarly, I can write for the b, it's a b plus 1 and so on. It is a b plus n minus 1. Same you can write for the denominator. You can see it's a 1, 2. It's a AP. So the last term will be n minus 1 and c plus 1 and so on. Fine. If you consider this is my first term, this is my second term, you can ignore the first term. Then it will be the n. Fine. It's a 2. It's a 2. Now can you find the value of the an plus 1? You can replace n minus 1 to be. Now you can divide them. If you divide them, everything will be cancelled. The remaining term here. How you can compute the limit? I can divide the numerator and denominator by n of the each term. It is an, it is b over n, it is 1 plus 1 over n, and it is c over n plus 1. So the limit will be 0, 1, 1. So it's a 1. Hence, the radius of the convergence will be 1 over limit as n approaches infinity is 1. Again, you can see is z raised to power n. So z minus 0 is 1. So this 1 is called as the radius of convergence. Okay, look at this another one. Again, your target is to find the radius, center and intervals. Can you find the an? N 4 is to power n square plus 1. So limit n approaches infinity, an plus 1. Or you can also use the second way, like as I tell you, you can use any formula at any time, but make sure you have to do the calculation properly. You can use this formula as well, like I can calculate the limit n approaches infinity. What is the raised to power 1 over n? So it is n raised to power 1 over n. It is a 4 raised to power n will be cancelled out. It is n square plus 1 raised to power 1 over n. Now we all know n raised to power 1 over n will be the 1 as n approaches infinity. So it is a limit n approaches it's a 1, it's a 4. I can take an n square as a common. So n raised to power 2 over n is outside. 1 over 1 plus n square raised to power 1 over n. Now if you take the limit, again n it goes to the 1 as n approaches infinity. So it is 1 over 4 into 1. This value will goes to the 0. This value will goes to the 0. Anything power 0 is my 1. So you can see the answer is my 4. Fine. Or you can use this formula an plus 1 over an. So I can use this value. So you can see 4n will be cancelled out. 1 over 4 is outside. Limit n approaches infinity. N plus 1 over n. I can write like this manner. And for this case, I can divide it by n square. Numerator, n square for the denominator. Fine. Now you can take as n approaches infinity. This value will be 1 over 4, 1 plus 0. It is 1 plus 0. It is 1 plus 0. So the answer is 1 over 4. So you can see the answer is 1 by 4. Therefore, you can compute the value of the r, which is 1 over limit n approaches infinity, and you can get the 4. Therefore, you can find the interval of convergence is z minus 0 is less than r. Here, you can write also z minus 0 is less than r. Now, the coefficient of z is again 1. So therefore, the center is my 0. Radius of the convergence is my 4. Look at the next one. Again, your target is to find the center, radius and the radius of the convergence. What is my an? N factorial over n raised to power n. So I can start with this case again. Limit n approaches infinity, an plus 1, n plus 1 factorial over n plus 1, n plus 1, n raised to power n over n factorial. So it will be limit n approaches. I can use the factorial and factorial. It is n plus 1. I can take n raised to power n. I can make as a separate n plus 1 and n plus 1. So 1 n plus 1 will be cancelled out. And you can see I can take the raised to power n is a common. The inside term will be n over n plus 1. I can divide the numerator and denominator by n. It will be 1 over 1 plus 1 over n raised to power n. So can you find the limit of this? It will be e. So therefore this r value, if you substitute them, it is a 1 over e, that is 1 over e, it will be e. Fine. So therefore you can find the interval of the convergence is z minus 0, coefficient of the n is y1 is less than e. So therefore the center is 0, radius of the convergence is e is my right answer. अगेन मैं बार बार कह रहा हूं बच्चों, CSIR नेट गेट में 2 क्वेश्चन डेफिनेटली आस्क, एंड फॉर द PY क्वेश्चन सीरीज हाउ यू कैन सॉल्व विद द previous year paper, you can watch my this lecture of the radius of convergence. Also you can see the power series lecture if you are interested. Okay, look at this another one. Again you can start with the an, you can substitute the value as n approaches infinity, an plus 1. Now how you can solve them? I can make the factorial term. It is n plus 1 square and n factorial square will be cancelled. Again I can open the value of the 2n plus 2, 2n plus 1, and then it's a 2n factorial that will be cancelled through this case. Fine. How you can solve this how you can solve this limit? How you can solve? I can divide it the numerator and denominator by n square. So that the value of the numerator will be 1 plus, and the denominator will be 2 plus 2 over n, and it will be 2 over 2 plus 2 over n. So what is the answer when you take n approaches infinity? 1. It is a 2 into 2, that is 1 over 4. So I can substitute the value in the radius of the convergence, sorry, in the value of the r, you will get 4. Again you can find the interval of the convergence. Z minus 4 is z minus 0 is less than 4. Again you can see the coefficient is 1, center is 0, radius is 4, and this value is my interval of convergence. Look at this next one. Again it's very simple. You can see an will be my n raised to power n. Fine. Now it involvement of the power n, I can start with this quantity. It is limit n approaches infinity. This is my n, so the answer is my 0. So therefore the value of the z minus c is, for this case, is less than 0, and you can see the center is 0, radius of the convergence is 0, and the interval of convergence is mod of z less than 0. Mod of z less than 0 means z is equal to 0 only, because the value of the mod z can never be negative. Look at the next one. Find the center and the radius of the convergence. Your an will be 3 plus 4 iota raised to power n. Again it's a power n, so you can start with this quantity. It is limit n approaches infinity, 3 plus 4 iota. So what is the modulus of the x plus iota y? The modulus of the x plus iota y is x square plus y square. So the answer of this problem is limit n approaches infinity, that is root 9 plus 16, that is 5. So the answer is 1 over 5. So therefore again you can see it is a z raised to power n is less than r, and thus this 0 is my center, 1 over 5 is my radius of convergence. Again in this case you can find the value of the an is minus. Fine. So you can start with the, again because the power n appears, so I can start with this case. Limit absolute value of raised to power 1 over n, it's a minus 1 over n raised to power 1 over n. What is the limit as n approaches infinity? As n over, so it is minus 1 over 1, so it will be 1. So therefore your center is my z minus 2 iota. So therefore z minus 2 iota, coefficient of the n is my 1, it is less than of r. So therefore c center is my 2 iota, radius is my 1, because the coefficient of the z is 1. I hope you can like and comment on the video as well. Look at this next one. This is the value of my an, so I can start with the an plus 1 over an. Can you find the value of the an plus 1? So it will be root of 2 n plus 1 plus iota divided by 1 plus 2 iota n plus 1 into 1 plus 2 iota n root 2 n plus iota. Is it fine? Now how you can find the limit? I can make the pair. I can make the pair of this value with the help of here. I can divide it by n. 1 over n root 2 plus iota over n divided by root 2 plus iota over n. For this case, for the other case, I can divide it by n. It is 1 over n and it is 1 over n plus 2 iota 1 over n. Fine. Now you can take the limit as n approaches infinity. So what will happen? It is 0. So the numerator will be root 2 only. Denominator is root 2. It is my 0. It is my 2 iota. It is 0. It is my 2 iota. Absolute value. So that will be my 1. Fine. So therefore, the value of the R is my 1 over 1. Therefore, Z minus 0 less than 1. So 0 is my center, R radius is my 1, and this is my interval of the convergence. Similarly, you can find the center and the radius. That's a similar one. You can start with the an plus 1. You can see from this case, it will be 2 raised power minus 1. So that is my outside. I can divide the rest of the term numerator and denominator by n square. It is 1 over n square plus iota 1 over n square plus iota 1 plus here. Fine. Now you can take the limit as n approaches infinity. This value will be 0. This value will be 0. This value will be 0. So it's a half iota divided by iota absolute value. It will be my half. Hence, the value of the R is my 2. Once you can compute the value of the R, you can use the interval of the convergence. Z minus 0 is less than 2. So therefore, center is my 0, radius is my 2. You can see again, as I mentioned you can watch my previous lectures on the radius of the convergence. That is very helpful for you. We will see the next lecture on the Taylor and the Lorentz series, that is the expansion of the. So we will see very soon the next lecture on the Lorentz series. Till then, you can share this video with your friends. Happy learning always. Thank you.